All right, so ready to dive into the history of maintenance with us?
Let's do it.
Get this, it goes back way further than you might think.
Oh,
We're
yeah.
talking millions of years.
Yeah.
You share some excerpts from a text on maintenance planning and scheduling, and it's got some visuals that really put things in perspective.
It's amazing to think about
Yeah,
how maintenance is like woven into the very fabric of human history. It's not just about fixing machines,
yeah,
but it's about that human drive to make things work
right,
and keep them working.
absolutely. So let's start with the basics. I'm guessing most people, when they think about maintenance, they think about, fixing something that's broken,
Mm-hmm.
what's called a run to failure. But there's also proactive maintenance and even
Yeah.
predictive maintenance, right?
You got it. So run to failure is reactive,
Mhm.
fixing only when something breaks.
Right.
Proactive maintenance is about scheduling tasks to prevent those breakdowns.
Okay.
And then there's predictive, which uses data to anticipate when things might fail.
Yep.
Uh-huh.
So you can intervene before they do.
So where does this all begin? I mean, did cavemen have a maintenance schedule for their clubs?
Well, not a written one,
Mm-hmm.
but figure 1.1 in your source material is incredible. It shows how maintenance practices had existed throughout human evolution. Take Australopithecus, for example.
Okay.
They were using tools like the chopper, shown in figures 1.3 and 1-4,
Okay.
as far back as 3 million years ago.
Whoa. So we're talking Stone Age repair and overhaul.
Yeah.
Were they actually fixing these tools?
Absolutely. So these choppers were the cornerstone of their technology for nearly 2 million years. They'd reflake and reuse them,
Wow.
showing an early understanding of resourcefulness and an instinct to keep their tools functioning.
That's wild. I
Yeah.
guess when your survival depends on a tool, you figure out how to make it last.
Right.
But things must have shifted once we moved beyond basic tools, right?
Yeah, definitely. A huge turning point was the invention of the wheel around 3500 BC.
All right. Figure 1.1 highlights this. Suddenly, you've got transportation that needs upkeep.
Yeah.
We're talking chariots,
Right.
and with chariots.
Races.
Yes.
And I bet those chariot races weren't just about who had the fastest horses.
Not at all. Think of it like a modern-day pit crew. The performance of a chariot, its speed, maneuverability,
Right.
was directly linked to how well it was maintained.
So we're starting to see that connection between maintenance and performance emerge really early on.
Yeah,
It's not just about fixing things, it's about making sure they work optimally.
exactly. Now, fast forward a few thousand years to the Industrial Revolution.
Yeah.
We see this massive leap in technology with water power transitioning to steam. Factories spring up as seen on pages 7 and 8 of your source.
Okay.
Um,
You'd think this would mean a leap forward in maintenance, too.
you would.
But wasn't this the era of run to failure?
Ironically, yes. Think about it.
Huh.
More complex machinery,
Right.
but less incentive to stop production for planned upkeep.
Yeah.
The focus was on maximizing output, even if it meant more breakdowns down the line.
So even though technology was advancing, maintenance practices were lagging behind.
That's right. But this changes with Henry Ford and his assembly line.
Mm-hmm.
His innovation wasn't just about cars,
Yeah,
but about efficiency in production.
right.
That constant flow of chassis on the line meant any breakdown had huge ripple effects, costing time and money.
I see. So Ford's need to keep that assembly line moving actually forced him to rethink maintenance.
Precisely. Page 10 of your text describes how Ford couldn't afford stoppages.
Right.
He needed his equipment to be reliable.
Right.
So he developed systems for regular maintenance. It was revolutionary at the time and significantly improved both quality and output.
So Ford was driven by necessity, just like those early humans with their choppers.
Yeah.
It seems like pressure often leads to progress in the world of maintenance.
That's a keen observation.
Yeah.
And speaking of pressure, nothing quite compares to the demands of war. World War I was a catalyst for so many innovations, and maintenance was no exception.
Right. You've got images of the Sopwith Camel aircraft in figure 1-6
Yeah.
and the Mark I tank in figure 1-7.
Mm-hmm.
These machines absolutely had to be reliable in the heat of battle.
Imagine being a pilot in a Sopwith Camel.
Yeah.
You can't exactly pull over to the side of the road if your engine sputters.
No.
The need for reliable aircraft and tanks pushed maintenance to a whole new level.
So what changed? How did they make these machines more reliable under such intense conditions?
Pre-mission checklists, for one.
Okay.
Rigorous inspections, preventative maintenance.
Mhm.
It was all about minimizing the risk of failure.
Right.
And these practices, initially born out of necessity during wartime, ended up shaping how we approach maintenance even today.
That's amazing. So those regular service checks we do on our cars are a legacy of World War I.
In a way, yeah.
It's fascinating how something so seemingly mundane has such a rich history.
It is. And the story continues after the war with another major shift in thinking. The rise of lean thinking, which originated with Toyota in Japan.
Now, lean thinking is usually associated with manufacturing,
Right.
but you're saying it also had a huge impact on maintenance.
Absolutely. The post-war boom led to larger plants with less product variety, as seen in Table 1.1.
Okay.
This meant fewer incentives for proactive maintenance,
Mhm.
leading to lots of breakdowns and a reactive approach.
I see.
Lean thinking aimed to change that.
Okay, so let's unpack lean thinking a bit.
Go.
How did it change the way people thought about maintenance?
It shifted the perception of maintenance from a necessary evil to a strategic advantage. It was no longer just about fixing problems, but about preventing them in the first place.
Okay.
And central to this shift were the 3 fundamental laws of manufacturing maintenance outlined on page 16.
Hold on, I need to grab a pen. This sounds important.
The first law states that properly maintained equipment makes many quality products.
Got it.
The second, that improperly maintained equipment makes fewer products of questionable quality.
Okay.
And the third, that inoperable equipment makes no products at all.
Wow, that third law is a real wake-up call.
Right.
I guess sometimes the simplest statements are the most powerful.
Absolutely.
So lean thinking argued that maintenance is crucial for quality and output.
Exactly.
So,
It's about maximizing value and minimizing waste, including the waste of downtime and inefficient maintenance practices. This was a radical shift in thinking that really revolutionized the field.
so we've gone from cavemen reflaking their tools to Henry Ford's assembly line,
Yeah.
from the pressures of World War I to the efficiency of lean thinking. It's been quite a journey already.
It has.
But this is just the beginning, right?
Just the tip of the iceberg. In our next part, we'll explore how these ideas evolved into modern maintenance practices and delve into the cutting-edge world of predictive and even prescriptive maintenance.
I can't wait to see what the future holds. But for now, thanks for joining us on this deep dive into the history of maintenance. We'll be back soon to wrap things up and explore what the future holds for this essential field.
Welcome back to our deep dive into the history of maintenance. Last time we explored how maintenance practices have evolved from those early humans and their stone tools all the way to the emergence of lean thinking in the 20th century.
It's amazing how necessity seems to drive so much innovation in this field. From keeping chariots running smoothly for those ancient races to ensuring aircraft and tanks were battle-ready during World War I, it seems like pressure really pushes people to find new solutions.
It's true. And speaking of innovation, let's delve deeper into lean thinking.
Okay.
We touched on its origins with Toyota.
All right.
But how did this philosophy, which initially focused on production efficiency, actually transform the way we approach maintenance?
Right. We left off with those 3 fundamental laws of manufacturing maintenance.
Yeah.
Could you remind us what those are again and how they connect to lean thinking?
Absolutely. So these laws really highlight how lean thinking shifted the perception of maintenance from a cost center to a strategic advantage. The first law emphasizes that properly maintained equipment results in more higher quality products.
Makes sense. If your machines are in tip-top shape, they're going to produce better results. What about the second law?
The second law points out the flip side. If your equipment isn't properly maintained, you'll end up with fewer products and their quality might be questionable. It highlights the direct link between maintenance and the overall success of the operation.
And the third law, the one you called a real wake-up call.
The third law states that inoperable equipment makes no products at all.
Right.
Simple but powerful. It underscores that maintenance isn't optional, it's essential for production. If your machines are down, everything grinds to a halt.
So lean thinking takes this holistic view, recognizing that maintenance is crucial for achieving both quality and output. It's not just about fixing things after they break, it's about preventing those breakdowns in the first place.
That's the core of it. And one of the key principles of lean maintenance is total productive maintenance, or TPM.
Okay, TPM. What's that all about?
TPM flips the script on who's responsible for maintenance. It's not just the dedicated maintenance crew anymore. TPM emphasizes getting everyone involved, including the operators who use the equipment every day.
So instead of just running a machine until it breaks down, operators are empowered to take ownership of its upkeep.
Exactly. They become responsible for things like regular cleaning, lubrication, and inspections. It's about catching those small issues before they become big problems.
It's like that saying, an ounce of prevention is worth a pound of cure.
That's a great analogy. And this shift in mindset, combined with a focus on using data to make informed decisions, has had a profound impact on how effective maintenance operations can be.
But even with preventative maintenance, things still break down sometimes, right? So how does lean thinking address that reactive side of things?
That's where the continuous improvement aspect comes in. Lean thinking encourages a culture of constantly analyzing processes and looking for ways to do things better. If a breakdown does occur, it's not just about fixing it, it's about figuring out why it happened and what can be done to prevent it from happening again.
So every breakdown becomes a learning opportunity.
Exactly. And by consistently analyzing and refining maintenance practices, organizations can minimize downtime and maximize the lifespan of their equipment.
This all sounds incredibly efficient, but wasn't lean thinking developed decades ago? What about the more recent advancements in technology? How do those fit into the picture?
That's a great question. Lean thinking provided the foundation, but technology has taken these concepts to a whole new level. And that brings us to the exciting world of predictive maintenance.
I've heard the term, but honestly, I'm not sure I fully understand it. Is it like having a crystal ball that tells you when something is about to break?
You're on the right track.
Hmm.
Predictive maintenance uses sensors and data analysis to get a much clearer picture of how equipment is performing and to anticipate when it might fail.
So instead of just sticking to a rigid maintenance schedule, you're using real-time data to make more informed decisions about when to intervene.
Precisely. Imagine sensors tracking everything from vibration and temperature to operating hours and energy consumption. By analyzing this data, we can identify patterns and anomalies that might indicate an impending failure.
It seems like this could save companies a lot of time and money by avoiding those costly unplanned breakdowns.
Absolutely. And as technology continues to advance, especially with the rise of the Internet of Things, IoT, the possibilities for predictive maintenance are just exploding. We're talking about a future where machines can practically diagnose themselves.
Okay, that does sound a bit futuristic, but wouldn't that make human maintenance technicians obsolete?
Not at all. In fact, their roles will become even more important. Instead of just being fixers, they'll need to become analysts, interpreters of data, and collaborators with these intelligent systems. It's a shift in skill set, not a replacement.
So it's all about humans and technology working together to achieve the best possible outcomes.
I like that. But before we get too far ahead of ourselves, let's make sure we understand the progression here. We've talked about reactive maintenance, where you fix things as they break, and proactive maintenance, where you try to prevent those breakdowns. Then there's predictive maintenance, which uses data to anticipate failures. What's next?
That's a fantastic question, and it leads us to the very cutting edge of maintenance. Prescriptive maintenance.
Prescriptive maintenance. I have to admit, I've never heard that term before.
Think of it as the next evolution.
Mhm.
If predictive maintenance tells you what's likely to happen, prescriptive maintenance tells you what to do about it.
So it's not just about anticipating failures, it's about providing specific recommendations on how to avoid them or mitigate their impact.
Exactly. Prescriptive maintenance utilizes advanced analytics and artificial intelligence to not only predict failures, but to actually suggest the best course of action.
Okay, that is pretty mind-blowing. It's like having a virtual maintenance expert on call 24/7. That's the idea. It can suggest things like adjusting operating parameters, replacing a specific component, or scheduling maintenance at a particular time to minimize disruption.
Wow. But with all this talk of data and AI, are there any potential downsides or challenges that come with these advancements?
There are always challenges when new technologies emerge. One of the biggest hurdles with prescriptive maintenance is managing the sheer volume of data that needs to be collected, analyzed, and acted upon.
So it's not just about having the fancy algorithms. You also need the infrastructure and expertise to handle all that information effectively.
Precisely. And there are also concerns about cybersecurity and data privacy as these systems become more interconnected. These are important issues that need to be addressed as we move forward.
It definitely sounds like there's a lot to consider as we enter this new era of maintenance.
There is. But the potential benefits are enormous. By embracing these advancements and approaching maintenance strategically, we can move beyond simply fixing things to optimizing performance, reducing costs, and creating a more sustainable future.
This is all incredibly fascinating. We've covered so much ground already, but I know there's still more to explore. What else can our listeners expect to discover in the final part of this deep dive?
In our next installment, we'll shift our focus to the future of maintenance. We'll discuss emerging trends like the increasing convergence of information technology and operational technology, the growing emphasis on sustainability, and the evolving role of the maintenance professional in this rapidly changing landscape.
It sounds like we're in for another insightful and engaging discussion. For now, we want to thank you for joining us on this deep dive into the world of maintenance. We'll be back soon to wrap things up and explore what the future holds for this essential field. Welcome back to the deep dive. We've journeyed through the history of maintenance, from ancient tools to modern predictive systems.
It's been quite a ride.
It has. But now let's explore what the future holds. What trends and challenges will shape how we keep things running in the years to come.
Well, the pace of technological change is only going to accelerate.
Yep.
We're already seeing the impact of AI, the Internet of Things, and the power of big data on how we approach maintenance.
We talked about prescriptive maintenance last time,
Right.
which uses those technologies to analyze data and actually recommend the best course of action.
Yeah.
It feels almost like science fiction.
It does, but it's becoming reality.
Yeah.
And as those technologies evolve, we'll see even more sophisticated applications. Imagine self-diagnosing machines that automatically order replacement parts or even schedule their own maintenance.
Whoa, that would be a game changer. But where does that leave the human element? Will maintenance technicians become obsolete in this high-tech future?
Not at all. In fact, their skills will become even more critical. They'll need to evolve from fixers to analysts, interpreters of data, and collaborators with these intelligent systems.
So it's not about replacing humans, but about augmenting their capabilities.
Exactly.
Humans and machines working together for peak performance.
The future of maintenance will demand a blend of technical skills, problem-solving abilities, and a deep understanding of these complex systems.
And what about the environmental impact? How does sustainability factor into the future of maintenance?
Sustainability is becoming essential in every industry, and maintenance is no exception. We'll see a greater emphasis on extending the lifespan of assets, minimizing waste, and adopting eco-friendly practices.
So things like biodegradable lubricants, responsible disposal of hazardous materials, that sort of thing.
Absolutely. And we'll see the rise of circular economy models where parts and components are refurbished and reused instead of being discarded.
That's a really intriguing concept. Makes sense economically and environmentally. Are there any challenges to making these sustainable practices widespread?
Of course, standardization and collaboration are key. We need industry-wide standards for sustainable maintenance and incentives for companies to adopt them. It's a complex issue, but essential for a sustainable future.
It seems like there's a lot to figure out,
Yeah.
but the potential is huge. What other trends should we be keeping an eye on?
The merging of IT and OT,
No.
like information technology and operational technology.
Can you break that down for us? What does that convergence look like in a practical sense?
Traditionally, IT and OT were separate,
Mm-hmm.
but with smart factories and the IoT, those lines are blurring. We're seeing integration between systems like ERP Enterprise Resource Planning
Okay.
and OT systems like SCADA, which stands for Supervisory Control and Data Acquisition.
So we're talking about data from sensors on machines being fed directly into business systems, giving real-time insight into performance and maintenance needs.
Exactly. This real-time visibility enables better decision-making, optimized maintenance schedules, and reduced downtime.
It sounds like the future of maintenance will rely heavily on data connectivity and intelligent systems.
It will.
But we can't forget about the people involved. How can we ensure that maintenance technicians are prepared for this rapidly changing landscape?
That's crucial. We need to invest in training and education programs that equip technicians with the skills they'll need in this digital age. Think data analysis, cybersecurity, working with AI, a whole new toolkit.
It seems like the future of maintenance will require a new breed of technicians, someone comfortable with both a computer and a wrench.
Exactly. And it demands a shift from simply reacting to problems to proactively solving them.
This has been an incredible journey. We've covered so much ground, from the earliest tools to the potential of AI-driven maintenance. But what does this all mean for our listeners? Why should they care about the future of maintenance?
Because maintenance impacts every aspect of our lives. The reliability of our transportation, the safety of our food, the availability of energy, it all depends on maintenance working effectively behind the scenes.
So by understanding these trends and challenges,
Yeah,
we can be more informed citizens and consumers.
absolutely. And we can appreciate the ingenuity and dedication of the people who keep our world running smoothly, often without much recognition.
Well said. As we wrap up this deep dive, I want to leave our listeners with a thought to ponder.
Okay.
What can we as individuals and as a society do to support the evolution of maintenance and ensure it continues to meet the challenges of the future?
It's a question worth considering. We've come a long way from those first chipped stone tools, and the future of maintenance is full of exciting possibilities.
That's a great note to end on. Thanks for joining us on this deep dive into the world of maintenance. We hope you've gained some new insights and are as excited about the future of this field as we are.